So I hope I am audible to everyone. So today we will solve another problem from the LeetCode, and that problem is intersection of two linked list. Okay, so let's first understand what is a problem. So in this problem we have given a two linked list. Okay, so this is a uh, first linked list, and this is a second linked list. And in this linked list we have to find uh, what is the intersection point between these linked lists. So you can easily see the 4 is the intersection point of the two linked lists, so we will return 4 here. And let's take another example for better understanding. So in this example, the first linked list is 10 20 30 40 and 50, and second linked list is 10 30 40 and 50. So intersection point is 30, because we can easily see that the intersection point is okay. So I hope you got the question. Okay, so let's move to the implementation part, how to solve this problem. So there are many steps included in this solving the problem. So this is the approach 1, and after the discussing the approach 1 we will discuss the approach 2. Okay, so in this first approach, the first step is find the length of two linked list. So first of all we find the length of two linked lists. That's the length of first linked list is 1 2 3 4 5 6, and second length of second linked list is 1 2 3 4 5 6, and 6 is has also length 6. So this is the first step. Let's move to the next step. So in the second step, find the difference between uh, length. But here length of a is equal to 6, and length of b is equal to also 6. Okay, so difference is 0. Okay, so the next step is if length is a is greater than b. Okay, let's take an example, like where take example another example. Let's like 10 20 30 40, and here the value is like 70 80, and the 80 points to 40. So length of here length of a will be 1 2 3 4 5. Length of a is 5, and length of b is 4. Okay, so here we will observe that length a is greater than length b, so we can find the difference. So difference is 5 minus 4, so difference is 1. So this is the third step. Okay, let's move to the next step. Okay, so and this is the second part is also similar to first part, like if length b is greater than length a, so in this case we can find the difference, otherwise it is similar to the first a part. So let's jump to the next step, and in this step now after the step 3 both pointer at the same level. Okay, and so forwarded both pointer where both pointer is equal, that's we got intersection point. Okay, so we can look this thing the help of example. So in the step 3 we find the difference. So after getting difference, what we can do, we can because here the length of 5 is greater than length of uh, linked list B. So we will increment the pointer how many times, whatever the difference. So you can increment the pointer from, let's, it is A pointer and it's B pointer. So we will forwarded the A pointer to here. Okay, and after the forwarding of A pointer, we are at the same level. Same level means if you observe that here is the intersection point, and before the intersection point we have only two nodes in the both, two nodes will be left in the both linked list, so we can say we are at the same level. Okay, so after this step we can uh, move the both pointer like A to here until we move, also move the pointer of B, and until we get same pointer value. So B is here and A is also here, so at that time A is equal to B. So if we get like this thing, so this is our intersection point. So okay, so let's discuss the time complexity. So time complexity is like in the view of n plus m. Okay, in the worst case we go of n plus n, and but in the two go like we solve this problem by iterating linked list two times. Okay, two times means for the first time we find the length, and in the second time uh, we find intersection point. So yeah, this is also a method. I will provide the uh, code into the description box. You can check from here. Okay. So let's move to the another method, okay, which is approach 2. So this is approach 2. Okay. There are many conditions like in this approach 2. Uh, there is a no need to find length of linked list. Okay, so okay, let's discuss the approach. Like in this approach there are many cases arises, like okay, we will discuss first cases here. So in the first cases have in the intersection and same length. Let's this is a linked list where intersection point is happening in that the C, and they have same length. So in this problem we can't is to like difference, we just increment the both pointer. Initially the pointer is here, and after the first step the pointer is moved to here, and second step pointer is moved to here, and for last step like fourth step pointer is moved to here, and this time A will be equal to B. So in that cases we get an intersection point, like we get an intersection point at node C1. So basically it's return C1. So let's discuss another cases. So in the another cases we have intersection but different length. So in these cases how can we solve this problem? So initially the pointer is here, both pointer is here, so move to forward both pointer to here, and then move to forward the both pointer here to here, and again we increment the pointer, and they their look lies here to here. So after that, after the that A will be reached at the null. So when any pointer, okay, so when any pointer like reach the, like in the here, uh, B is here but A is pointing to null. So in this case we can assign B1, like B1 is second linked list, and we can assign B1 into A. So now A is here, okay, and B is and after that is also null, so we can assign A1 into B. Alright, so B is here and A is here. Then we again increment the pointer, both pointer, and at that time at this node C1 they meet. So if any pointer will meet, so we can say that this is an intersection point. We got the intersection point. Okay, let's move to the another cases. So in the another cases, no intersection but same length. So in these cases we just increment the pointer like here to here and then here to here, and A, after that A and B both are pointing to null. So it is, yeah, here also A is equal to B, but the value of A or and value of B will be null. So in this case it will be returned null because of they reached at the end. So we will simply return null value. Let's discuss another cases here. So in these cases, no intersection and different length. So if the basic concept is we can move to the A pointer as well as B pointer until we get same value. Yes, until we get A and B pointing to same linked list. So initially A is here, B is also here, then after the first step A is here and B is here, then A is here, B is here, and then A is here, B in here. But at that cases B points to null. So in this case we assign uh, A1 into B. So B is here and A is also null here. So after the A pointing null, we also assign B1 to A. So A is here and B is here. Okay, then move to the next pointer. Okay, so right now B is here and so in that cases B is here and A is here, and then increment the B pointer, so B is here, and also increment the A pointer, and after reaching the B and A both are pointing to null, so it means we get an intersection but at the null pointer. So it means we uh, we didn't get any intersection point, so we will get null pointer intersection point. So okay, so yeah, this approach is like a tricky one. Okay. So we will just discuss the code, because code part is not much lengthy, it is just simplest one. So in the code part, what can I do with it? This is a base case. If anyone node is null, so this is the obvious thing, we will return null, because if anyone node is null, so it means we didn't get any intersection. So this is the initialization part. We assign head A into A and head B into B, and we run a loop while until A will be equal to B, and this is the condition, like focus on the condition if A is equal to null. So in this that cases we assign head B into A, otherwise we will move to the A pointer. And similar for the B, if B is equal to null, so it means if B is equal to null, so we will assign head A into B, otherwise we move to the B pointer. So, and after the coming from after the breaking the loop from while loop, we will return A. Okay, so let's take an example for the better understanding, like 10, 12 and 30 and null. Here I will take 40 and 30. Okay, so this is our example. So initially this is the A and this is the B pointer. So and in the first case there is a no linked list will be null, so we can't return null. Okay, so we assign head A and head B into A and B. Okay, we already assigned here, and make a loop. Either way A will be equal to, but in this case A will be not equal to B, so increment the pointer. Okay, and also no one can be null, so increment the pointer to here. So B is at the here, and we will just increment the pointer, and A is at null pointer. So we jump to the second condition. So in the second condition, if B is equal to null, so we can assign head A into B. So I also it is for the declaration. Okay, so at that time B will pointing to node A. So B is here, and we increment the A. Okay, so after that A is also equal to null, so we assign head B into A. Okay, so after the iteration we increment the value of B to here, B, and then B, and after the first iteration A is here, so at that point, like A and B both are pointing to 30, so we can say that it is a condition where we out of loop while loop, because here A is equal to B. So in this case we will return A. So whatever having A, so we will return A. So A is having 30, so we will return, so 30 is our answer. Okay, I hope, yeah, you get the problem, get the solution. Thanks.